right before our eyes. And if it's been interesting so far, it's going to get downright weird in the next 15 or 20 minutes. I promise you that. So we're going to go to a station ID break, and we're going to be back after just a few seconds. So stay with us for continuing coverage of the live lunar eclipse. I'm Bob Berman.
You're listening to SLU Space Camera's live total lunar eclipse, powered by WSRadio.com, the worldwide leader in Internet talk.
Hi, this is Bob Berman with SLU Space Camera and with Google presenting you the live lunar eclipse seen from the Asian side of the world. We're watching the moon go more and more into Earth's shadow, and joining us for this next hour, I'm happy to introduce Dr. Duncan Kopp. And Duncan Kopp is who grew up in southwest England, got a master's degree, holds a master's degree in satellite remote sensing. That sounds cool, doesn't it? And a doctorate in astronomy, both from the University of London. He's done all sorts of very, very cool things. This is a very cool guy, and I looked at his picture too. He even looks cool. He, I'm going to cover up some of the very, for other people this would be cool enough, but I'm going to even skip the lesser cool and go to what, to my mind, is the most cool, which is that a few years ago he conceived, developed, and produced the acclaimed feature documentary In the Shadow of the Moon, which was an intimate story of the Apollo astronauts, and this won all sorts of awards, including Best International Film at the 2007 Sundance Film Festival. It sold about 500,000 copies. I just got myself one in Blu-ray, and maybe you'd like to do it too. There's another thing he did that I like a lot too, and that's in 2007 to 8 he developed and produced and co-directed a thing called Moon Machines. It was a 6-part series for Discovery's Science Channel, which recounted the trials and tribulations of the engineers who built the machines that took the Apollo astronauts to the moon. And more recently, he's developed, directed, and produced The Planets, an HD Odyssey. Now, this is really interesting to me because the Holtz composition, Holtz, The Planets, we all know of it. To me, that was always like a dreary thing that was suited to narcoleptics. But he's made this instead into an exciting thing with the Planet Suite, which was commissioned and conducted by the Houston Symphony, and with that and with images around it, people have been wowed and knocked over backwards, and this has been an amazing thing that's produced more of an audience. It's the highest-grossing production in the 100-year history of that Houston Symphony. And there's a lot more. Maybe I'll talk about more of that later. But enough yakking as we're watching this lunar eclipse live. Let's welcome Duncan Kopp.
Hello,
Bob. Are you there, Doug?
I'm here. Can you hear me?
Oh, absolutely.
Great. Well, I'm glad it's online because I'm sitting here at the Mayflower Studios here in the heart of Soho in London. And, of course, it's cloudy, so we can't see a thing. But thankfully, I've got my trusty laptop here, and I can see the feed, and I can see we're about halfway through the eclipse at the moment. So thank goodness for SLU.
Oh, yeah, it's great to have you, and I can tell the people who've been listening so far, Duncan's a great guy. He's a lot of fun. I wish we had callers on this show because this is a hoot that we're having. And Duncan, would you agree that we're just now entering kind of the weird part of the eclipse?
Yeah, I think so. I mean, I was listening to you earlier, and for those viewers around the world who can see it, if you stick your head out or have a look on SLU, it doesn't look that unusual. It looks like a sort of semi-crescent moon, or almost a half moon. But of course, all that's going to change, and the real fun stuff is going to kick off fairly soon when we finally get to totality, and the moon just goes this fantastic coppery colour. And I remember seeing that as a kiddie, years ago for the first time. And quite honestly, it's a sense of, you feel really little because you sort of remember that there are things out there, there are celestial events that don't happen all that often, but when they do happen, there's a certain grounding. There's a certain sort of sense of awe, I guess, really. And to think that the moon is going to be totally within the Earth's shadow and has that wonderful coppery colour. Of course, the real excitement is nobody really knows quite how coppery it's going to go. And as you were telling us earlier, Bob, that depends on just how much particulate matter there is in the atmosphere. And recently we've had a number of volcanoes kick off in Chile, for example. So who knows how much material is up there at the moment. But a sure indication is the colour that the moon's going to go. And of course, if you were standing on the surface of the moon and looking back at the Earth, you would see a pretty spectacular sight.
I wish we'd ever send astronauts during that time. You're so right. It would be when it's fully eclipsed, it would be the black nighttime hemisphere of moon surrounded by a ring of fire. All the world's sunrises and sunsets forming one beautiful ring. And that ring of red light is the only thing that's going to be illuminating the moon coming up just
fantastic.
Minutes from now.
I'd never thought of it like that, but of course that's exactly what it is. It's the sort of the whole of the world's sunset and sunrises, sort of all focusing through that tiny veneer, that really thin layer of our atmosphere, which we have, and of course the moon doesn't. I'm sure it's only a matter of time before there are people who are able to look back and experience that. In fact, the Apollo 12 astronauts on the way back from their mission in November 1969, after the first mission with Apollo 11 and Neil Armstrong, they were fortunate enough to fall into the Earth's shadow as they were coming back. And I remember seeing some spectacular footage that they took of the sun disappearing behind this planet, our planet, the Earth, and really eerie stuff, but wonderful nonetheless.
Yes, absolutely. Notice, too, this is, of course, not to you, Duncan, but who know this backwards and forwards, but to our viewers and listeners, how that shadow that we're seeing has not changed its shape since the very beginning of the eclipse, because we're seeing an arc, a section of Earth's shadow. Well, that's the same size and the same arc that it's always going to be. So from the beginning of the eclipse till now, that's invariant. What changes is that as it sweeps over various parts of the moon, it sometimes gives the illusion that we're seeing a day-night shadow on the moon, but now no longer could we pretend that, because even now the moon has become not a normal crescent phase that could ever be seen during an ordinary month. Even now the moon is, when do you see this in the sky? And for this remaining it's only about 14 minutes now before the total part of the eclipse begins. That what's left of the sunlit moon will take on a stranger and very unnatural appearance. This is my favorite part of the eclipse.
I think it's really cool, that shadow. If you think about it, that's probably one of the most important shadows ever, because as you were talking to us earlier, Bob, you were saying that it was really instrumental in understanding that we live on a globe and not on a flat planet that of course our predecessors once thought, and those who had the insight to observe these kind of events, it really was an eye-opener for them, and obviously a real cornerstone in the foundation of the fact, we're on a globe.
That's right. It's too bad that for thousands of years after that, after the ancient Greeks realized this, that most people still went on thinking we lived on a flat plane. In other words, it wasn't enough for them, the evidence right before their eyes. But yeah. I guess we shouldn't get you and me started on that kind of thing. Because you're doing a great job in bringing space to the public, even people who don't know any astronomy at all. And so you should get your own medal for doing that and opening everybody's eyes to that. I understand that you've also recently conceived and directed and produced something called Inside the Milky Way, a 2-hour documentary for National Geographic.
Yeah, that was a lot of fun. The premise of that film really was to take the viewer on this sort of journey across our galaxy. And you can think of our galaxy as a city, because it's it's not dissimilar in many ways. It's got downtown, which is the center of our galaxy, where there's the hustle and bustle, and the density of stars down there is pretty high, and that's because astronomers are pretty sure that at the center of the galaxy is a pretty large black hole which has this huge gravitational attraction. So a lot of stars cluster down there. It's a vibrant place. It's a busy place. For life, perhaps it's a dangerous place. But then, you can always go out to the sort of leafy suburbs, out to the outer spiral arms where things quieten off a bit. And in fact, a lot of the stars that you find out there, they're a little bit middle-aged. They're not so adventurous. They just sit there and don't do much for sort of billions of years, really, on a cosmic scale. So the whole premise of that show was just to sort of take people around our Milky Way galaxy, a collection of about 100 billion stars, almost incomprehensible number that, but and show them these places where stars are born, places like the Orion Nebula M42, places where stars die, like the Crab Nebula, which was a very spectacular sight, actually, that was observed by the Chinese astronomers. They actually saw this star blow up, and in fact, if you go and look where that star is now, you ain't going to see a star, but you're going to see a very, very rapidly expanding cloud of gas and dust, which was the remnants of that star. And we wanted to take people on this journey, and that really was the premise.
Good for you. And by the way, I hope people listening here do just that. I understand there's a special offer from SLU. I don't want to sound here like a salesperson, but you click on SLU here and become a member, and you can see the Crab Nebula that Duncan was talking about, and you can actually see the pulsar. Imagine a star that's smaller than Los Angeles. Can you imagine that? Can you imagine a star that spins 30 times a second? We can actually see that happening in all of it, the violence of that kind of speed and activity, and some strange glows, synchrotron radiation. Just we're seeing colors that you can't see almost anywhere else in the universe that are caused by little subatomic particles, electrons being forced to change their direction because of the strong magnetic fields. You only see that in a few places in the universe, but you can actually see that for yourself at night. And if it's not on the schedule, you just press a button and make the telescope point there. You direct it yourself. It's SLOOH. I love SLOOH. SLOOH. I mean, they're responsible. The reason I'm talking it up is it's really thanks to SLOOH and, of course, Google and Paramount as a sponsor for making this eclipse possible. And now that we've been speaking about the Milky Way and the eclipse, look at what's left, Duncan. Look at that little sliver. Now we can no longer pretend for 1 second that we're looking at a normal phase of the moon. This is obviously something. Imagine seeing that in the sky, just like a little piece like that, and if you didn't know that an eclipse was underway, what would you think? That's not a normal moon, is it?
No, it certainly looks very unnatural, and you can understand why people of old would look at something like that and think, hold on a moment, that's not supposed to happen. What exactly is happening? Even more so when you have a total solar eclipse, when of course the moon passes in between the sun and the earth, and they're, as you were saying, Bob, earlier in the show, a lot more spectacular. They're a lot shorter. But just imagine if you didn't have that prior knowledge and you suddenly see your sun. Just about every civilization depends on the sun, and it just goes, and you can't explain that. No wonder it would put the sort of a fear into you. Of course, today it's a spectacular event, and it allows us to see an area of the sun that you wouldn't normally see. This
spectacular.
Superheated
so right. So try, everybody. Try to get to a total eclipse. There'll be one next year on November 13th in Australia. I guess I should mention, because I'm not making any money from that a science tour company started something called Bob Berman Tours. I'm Bob Berman, so it sounds like I'm touting it for some kind of gain, but I'm not getting a penny from that. The idea is to get people to Australia or to under the Northern Lights easily, cheaply, without a hassle. And if you go on bobbermantours.com, that's going to tell you how to get to Australia just easily next year for the total solar eclipse. And if you don't use this, find your own way to go, because just as Duncan has just been speaking about total solar eclipses, which if you think this is great, a total solar eclipse makes people weep, makes animals go crazy, people weep.
It's the most bizarre experience. We had one that just clipped the United Kingdom in August 1999. And a group of us sort of decided to go and see this. And the weather wasn't fantastic, but we had a small break in the clouds. We were really fortunate. And we were on the island of Alderney, which is in the Channel Islands between the UK and France. And I tell you, it's just the most bizarre thing. You see this shadow creep up, and it came across the ocean. And Alderney's a tiny, tiny island, and it was absolutely inundated. There were.
Did you really get a clear breakthrough? I didn't know that anyone who saw it from England.
We had a very well. It was high cloud, so we were able to just about see what was going on. And when totality happened, you really are standing in the shadow of the moon, and there were just nobody bothered to turn their flashes off on their cameras. So it was just just a whole glittering island. It was incredible, and lots of weird things. We could hear Concorde because they were at that time Concorde was flying, and of course Concorde is was a pretty fast aircraft. Even when it wasn't going supersonic, it was subsonic. But you could hear it above because they were taking people on Concorde, flying along the path of totality. This is where the moon traces out the shadow on the surface of the Earth. So the people up there, I'm sure, were having champagne and having a much longer period of totality as Concorde races the shadow that's racing across the Earth's surface. But no, great time. We had a ball.
I'm glad you had a great time. Generally, and I'm going to tell this to the listeners and viewers here, when there's a total eclipse of the sun, the path is only about 150 miles wide, so you usually have a choice of places. Don't do what Duncan did. Don't go to Western Europe the next time there's an eclipse there. I was the eclipse astronomer on the Black Sea. That was better. That was clear. That was a sunny day. So to do that, I'm glad to hear. Duncan is just telling me of the very first reports I've had of anyone who saw anything from England or France, because I know it was overcast there. So good for you. I mean,
well,
hats off to you.
No, we were really, really lucky. I mean, it wasn't ideal, but it was enough to get a sense of what was going on, but fleeting. And as you say, the weather here in UK, it's pretty predictable, and that is rainy.
Might you go to Australia next year for that one?
Oh, I'd love to. Yeah, no, I'd love to if I got an opportunity to go out there.
Hey, join us on that thing, Bob Berman Tours. Just go on it, do that.
Sounds fantastic.
And, maybe you can lecture with me on that. We'll talk about
possibly.
Hey, look at this eclipse. Meanwhile, notice the red is coming in.
Yeah, you can see it now, can't you? That's just starting to creep in there. Wow, look at that.
And so already we can tell you the world is not going to end. The Earth shadow really is coppery red, which is the normal color. We can already give you the news.
Isn't that spectacular? Look at that.
Yes. Aren't you glad, by the way, that this eclipse is not happening on December 21st, 2012? Imagine that, because that would be like one final sign of the end of the world, wouldn't it be? This to me is my favorite from here to when totality begins, which is just going to be a few short minutes from now. Is my favorite part, because you see the red, you still see a little tiny bit of the sunlit part of the moon on the right, and in a few more minutes when that gets smaller, I think it's going to look all the world like the planet Mars with its polar. There, even now. With the rest of it looking very Mars colored,
look at that.
And a polar cap on the right.
So Bob, what would the temperature be now? Because obviously it must be plummeting now that the surface there is in the shadow of the Earth. It must really drop very quickly there.
That's right. Now, as you know, the daytime temperature, especially near the center of the moon, on the middle of the solar day on the moon, is about, in Fahrenheit, we're here in America, we're still Fahrenheit, and so it's about 240, 250 degrees. At night, easily enough, it falls to about that same temperature, but below zero. But will it drop that much in just a few hours without sunlight? No. So what we have to think of is, what would sand, essentially, silicon dioxide,
Uh-huh.
what would that do in the absence of sunlight over a period of only a couple of hours with no atmosphere? Of course, here on Earth we have an atmosphere that acts as a little bit of a blanket and stops it. On the other hand, the lack of an atmosphere makes the moon's surface a little bit like a thermos jug. In other words, the heat cannot dissipate to somewhere else. It doesn't have air to dissipate to. The vacuum acts like a protective way, so that the surface has a little more trouble dissipating its heat. So the bottom line is you're asking how much colder the surface will get, and I would guess that it's only during the eclipse, it's only going to drop maybe 20 or 30 degrees, but that's just a guess.
Okay.
What would you
so
think?
that's not as, I mean, when we were, you were mentioning moon machines there, and some of the engineers that I spoke with when we were researching and making that series, one of the biggest problems they had was this really big change in temperature, because, of course, if you're on the lunar surface, if you're in full sunlight, it's incredibly hot. But if you move into the shadow, you're dropping 200 degrees Fahrenheit or almost instantaneously. And in fact, what they had to do with the command module, that was the very top of the Saturn V rocket that basically blasted them into Earth orbit and then onward to the moon. They had to roll this spacecraft, and they called it the sort of barbecue maneuver, this rolling of the spacecraft, so that you would sort of equilibrate the temperature. So it was a bit like a chicken on a spit, and if you want that chicken to be evenly cooked, you got to roll it on top of the coals. And it was the same for the spacecraft. And I was told a lovely story once that I think it was Apollo 8, it would have been Apollo 8, which was the first time that the command module went to the moon, that astronauts went to the moon. They only orbited the moon, they didn't land, they just went to the moon. And they were all looking at their sensors, and all of a sudden somebody said, hold on a moment, the spacecraft's getting really cold. What on earth is going on? This was something they didn't know what was happening. And they thought, well, do we have a problem? Is there something wrong with this? And of course, what had happened is they'd gone into the shadow, and the shadow meant that the sun was no longer heating the spacecraft, and it started to drop in temperature. I thought that was a really lovely story.
Yes, and I'm glad the engineers thought of all those things ahead of time. You'd think that there'd be things that they overlooked.
With that particular event, I think it was something that got the hairs on the back of their necks sort of standing up a little bit, until they thought, no, hold on, we know what's happened here. They've finally gone into the shadow, which was very interesting.
Yes, and as we are now fully going into Earth shadow, as we're watching the moon, now distinctly red, but look at the left side of the moon. That looks quite dark. So in another hour from now, when we are more fully within the shadow, or let's say 45 minutes from now, I wonder how dark the moon is going to be then. And, talking about the Apollo astronauts, one of my favorite stories was, of course, Apollo 12, which was a very convivial crew. Apollo 11, when I interviewed Buzz Aldrin, of course, nobody gets to talk to Neil Armstrong, but one of the things that they admitted, and then Michael Collins said, is that although they were all very professional, they were all really great at what they did, they had a job to do, and they did it. It was cool. It was professional. But none of the others, this is afterward, this came out, none of them let the others in to his private thoughts, his feelings. They weren't friends. And even though Aldrin said that years later he had suggested an annual reunion, it never happened. And there was no close camaraderie. But on the Apollo 12, the people there, they were friends. The people who were doing that, Alan Bean and the others were all, they were friends before, they were friends afterward. So when they took off and their Saturn V rocket was struck by lightning, and the whole panel lit up with all these alarms and stuff like that, and they said, hey, we lost everything. Everything in the world's dropped out. And they had no idea what was going on. All the electrical dropped out, and they were They were on battery power. Nobody had ever seen anything like that. Everyone on the ground thought any moment there'd be the order to fire the escape tower rockets, and they'd pull the capsule away, and this mission was going to be scrapped. But because the problem seemed to be electrical, the flight director turned to his electrical expert, and this was that controller John Aaron, who later became the hero on Apollo 13, some months later. But he was looking himself at the screen, and he was just amazed. He remembered that he'd seen this pattern long ago during some kind of crazy simulation, and suddenly he remembered, and it came to him what should be done. And he told the others. He said to the flight director, "Tell the Capcom, the guy who talks to the astronauts," he said, "tell them to switch the FCE to auxiliary." And the director said, "What? What's that?" But he had the Capcom do it anyway. He said the exact directions. He had it relayed to them, and the astronauts, when they got that command on Apollo 12 with all the crazy alarms going off and all the electricity off, they said the same thing the director said. They said, "What? What's that? What's the FCE to auxiliary mean?" But Alan Bean, he knew what it was. He knew where it was. It was a never-used switch, a little tiny switch among one of the gazillion switches that were on a panel over his shoulder. So he flicked it, just as he was told, to auxiliary, and all the power and the gauges and the lights and the controls, all of them promptly came back, and the mission proceeded normally. And this one electrical guy in mission control, he's the guy who knew what to do in this insane lightning strike as the thing was going skyward. So, Duncan, when you're talking about, like, you never know, what kind of conditions are going to happen, and are they prepared for everything? It's so true. Yeah. And that's what makes the Apollo missions so exciting to you and me and anyone who's had anything to do with them. And that's why the people who think it never happened, that it was done on a Hollywood stage set, why that's so crazy.
Yeah, no, yeah, you're absolutely right, and I think it's the story you told there just beautifully illustrates teamwork, and that's what I came away with, more so with Moon Machines, having sort of spoken to a lot of the engineers. It was a real camaraderie. Kennedy set the goal in the early '60s, and of course wasn't around to see it executed, and I think they all felt that after Kennedy's assassination that they just really wanted to carry on, but it was a sense of working together, teamwork, not giving up. They had umpteen problems. I mean, that's just a very trivial thing to say, incredibly difficult thing to achieve, but by working together they could make it happen, and everybody put 110% into that mission, as they do today in various areas of exploration. I think it's a trait of exploration. If you need it to, if it's going to succeed, it's got to be 110%, and I think that's borne out with all manner of areas of expedition. But picking up your point, we tentatively thought, well, do we ask the question, what do you think about the hoaxes, when we were making In the Shadow of the Moon? And we sort of thought, well, should we, shouldn't we? Well, yes, we should, because... Yeah,
you did, and at the end you had them all addressed.
Absolutely, because unfortunately it is something that the first thing people say to me when I was producing the film. A lot of people would say, yeah, of course, but it didn't happen, did it? So that's what they want to hear. So we asked everybody, and the retorts we had from the astronauts were hysterical.
They were good, and they were good retorts. They were good answers.
Of course they were.
One of them said, well, if we were going to fake it, why do it another 9 times after that?
Charlie Duke, who's just the nicest guy you would ever want to meet, and we've been to the moon 9 times. I mean, why would we fake it 9 times if we faked it?
Yeah, every time you fake it, you're going to risk being found out an extra time. Well, why keep doing it?
Absolutely. And Mike Collins, who was the command module pilot of Apollo 11, he's the chap that stayed in lunar orbit while Neil and Buzz went down and walked.